So,
Morning.
Younes, Jaaidi, welcome to the stream and welcome to Accento.
Thank you. Thank you for having me.
So
Pleasure.
we're excited to have you here as the opener for our JavaScript and web track. And it seems so far things are working out technically. What we would do is, as everybody knows or maybe doesn't know, is the talks are pre-recorded. So we'll be streaming the talk from a YouTube video. But maybe before we get started, you can give us a little introduction, like who you are, what your background is, and before we go into the talk.
Okay, so my name is Younes, and I'm the founder of MarmiCode, which is a company where we offer workshops and consulting on two main topics: extreme programming and testing. And the other
Okay.
topic is Angular, because I'm a Google developer expert for Angular, which might sound like, wow, weird, but it's just like we're in kind of, it's a special thing that gives us like kind of a relationship with Google where we're just trying to make the web better. So I'm a
Okay.
Google developer expert for Angular and also for web technologies. So we're trying to collect feedback from people like you here. So if you have any questions, just shoot. I'm probably not be able to answer, but I'll try to find out a solution or something. So
Okay.
anyway, so the idea is to bring information from what's happening behind the scene to the people and the other side too.
Excellent.
And so that's the whole thing. And the other topic is, of course, extreme programming. As I was born in like an extreme programming company somewhat.
Okay.
And so it twists your mind, and like I can't think of other ways of developing without TDD and things like that. And now I'm trying to figure out how you end up with this kind of state of mind and how you can bring that to people and what's the advantages and stuff like that. And that's another topic we can talk about later. There's during the testing panel, and also
Yeah.
I'm giving an Ignite talk about time box TDD and stuff like that.
Yeah, so Younes has a few sessions coming up after this talk related to testing. So I'm really looking forward to that. So then I would propose that I was thinking about asking you also questions afterwards about extreme programming and so on, but maybe we have to postpone those to the sessions then in the afternoon.
Yeah.
Okay, thank you very much for the intro, Younes, and I will see that we can add the talk to the stream. Then we'll stream the talk to the audience, and afterwards, please, people, keep write down your questions, put them in the chat, and afterwards we'll have plenty of time for discussion.
Hi everyone, how are you doing? Sorry, I can't hear you. Oh yeah, it's recorded. So I'll just assume you're fine, and I hope you are. I'm gonna ask you a question immediately. That's why I'm here today. Did you ever try to implement a live search form, like a form that keeps showing results while you're filling it? Well, I don't know how it went out for you, but I tried and I went through some trouble. And that's what I want to share with you today. So basically, what I wanted at the beginning was just a simple search input that shows results while I'm writing keywords in it. So for every keyword I'm writing it, I'm hitting my old grumpy backend that grabs some data in a database there. Problem is, if you have a quick typing user, well, it's going to send a lot of requests. So for every request sending, it's going to query the database. And it's going to burn up your CPU and memory usage. Well, you might say, I'm serverless, or my infrastructure scales automatically, so I don't care that much about that. Well, then you might care about the budget. And that's what I cared about too. So I cared about my performance and my cloud budget. So I had to figure out a solution for that. I don't know what you're thinking about right now, but the first thing that I thought about was adding some delay. I don't want to send all the requests. I'm going to wait for the user to stop typing, then go grab the data when I know that the user is waiting for results. So that's what we call the debounce. And this is how it works. You have a first stream, which is the stream of keys that the user is typing. These keys are constructed in the second stream, which is the stream of keywords. So the keywords are constructed that way. And I don't want to send 9 requests, 1 request for every part of the keyword, but I want to filter them and wait for the user to stop typing and then make my request. So that's how I end up sending 2 requests instead of 9, because I'm waiting for the user to stop hitting the keyboard for a while. Well, if you're familiar with RxJS, and so you'll quickly understand that. And if you're not familiar with RxJS, well, you should definitely check that out. And if you need any resources to start with, just let me know, and I'll can show you some links. But the RxJS documentation is really quite nice now, so you can definitely check it out. And so RxJS is a reactive library for JavaScript, and it's basically streams manipulation. So I have my keywords dollar, which is a stream of keywords, so the keywords that the user is typing, and I'm going to use the pipe method to transform that stream of keywords to the data I'm looking for, the data I want to show on my view. So this makes the data observable, the data dollar observable, that we can subscribe to grab the data, and I don't know, I'll call console log or do whatever we want. But the interesting thing here is not how we're going to consume it, but how we're going to make it. So with the pipe method, I'm going to add the first operator, which is the debounce time operator. So it's an operator here that will wait for 100 milliseconds and then use the last value. Okay, so every time the user types on a key, it starts the timer and waits for 100 milliseconds before emitting that value. But if the user types again, it's going to start the timer again, and we're going to wait 100 milliseconds. If the user keeps typing quickly, we're not getting any value. And afterwards, so I'm having only the keywords marmy, then marmy code, because that's when the user stopped typing. And then I'm using a switch map operator, which is one of the flattening operators we have with RxJS, and it has an interesting feature, which is that for every keyword, it's going to call the search function, which is an asynchronous function that will grab the results, but switch map will cancel the previous search. So every time we have new keywords, we are going to cancel the previous query. This is very interesting because we're going to have only one query at a time, and we're not going to have any race conditions or lots of queries sent simultaneously there. And that's the perfect use case here. So problem with this is that we're having artificial latency. We are adding artificial latency, which is quite a shame because it's been decades where people have been working hard to make the web faster, to make the networks faster, to create new crazy protocols, and then we're just adding 100 milliseconds latency in the browser. Well, so I didn't want that solution. I wanted something better. So I just removed the debounce. And this way, every time I'm sending a request, it's canceling the previous one. So I only have one request at a time, which is quite cool. But the problem is, what happens with the database? What happens with other microservices or other services I'm calling on the backend? I don't know. Is my cancellation propagated? I don't know. So that's what we're going to talk about today. We're going to talk about what happens when you cancel an HTTP request. So I'm Younes Jaaidi. I'm from Lyon, in France, and I am a Google developer expert for Angular and web technologies, and I'm the founder of marmycode.io, where we do our best to help you cook better apps through content, workshops, and consulting. So if you need any help with your apps, just get in touch with us. Okay, let's hit it. I don't know if you've ever heard about Nest.js, but it's just a JavaScript backend framework that brings typing and dependency injection and cool stuff like that. And it's quite based on Angular. So if you're familiar with Angular, you will find a lot of similarities in there, which is quite nice. So instead of listing all the features there, let's dive into some Nest.js code and see how it works. So as you can see here, if you want to add a route or something, you just have to create a controller, which is just a simple class. You decorate it with a controller decorator that says, okay, this controller handles the /files route. You can use the dependency injection in the constructor. So I can inject the file search service here, for example. Then you can add methods for every HTTP method. So I can have a method that it would, thanks to the get decorator, I'm telling Nest that this method will handle the get/files requests. And then we have a query decorator here I'm using to grab the Q parameter in the query string. And I'm putting it in the keywords variable. And afterwards, here, I'm free to run any code I want. And I just return the results synchronously, for example, here. And this will be sent as an HTTP response. Or combined with RxJS, I can also return an observable. So I'm return a stream of data, and because I'm running some asynchronous logic there, so I'm calling the file search service, and the search method on it is returning an observable, and I'm just adding a map operator that works just like a map on an array, which is just transform the results to an object with an items field and a total count, for example. But why would we use observables if we can use async await or promises? Well, one of the most interesting features with observables is that they are cancelable. We can cancel the logic, the task running behind the observable. So here's an example. As you can see here, we have an interval function that will return an observable that emits a value every period of time. Okay? We're using set interval, but as you might probably know, the set interval will keep running forever until we stop it. Problem here is that we don't stop it, and when we will unsubscribe from the observable because we're not interested in it anymore, it's not gonna stop the interval, and we'll have a memory leak and a CPU leak. So we have to grab the timer, which is the variable that the handler returned by the set interval function, and we have a last opportunity here to return a function called the tear down function of the observable that will allow us to clean up the mess we create when we make our observable. So when we unsubscribe from the observable, or when the observable stops and stuff like that, this function will be called so we can clear the interval, for example, in this case, or stop the logic or the task which is running in the background, kind of. So that's why we're going to use observables. Okay, let's try it out. I'm gonna need my coding apron assistant. Oh yeah, I don't have an assistant. Sorry. I keep forgetting. Okay. While implementing the file search service, I was looking for something really slow. So I thought about like big file and searching for my keywords in the big file. Well, it turned out to be quite fast. So I had to find something slower. And that's when I thought maybe I need a folder with lots of small files. And I don't know how I could create like an interesting folder like that. I thought maybe the source code at the beginning. Then I thought about maybe a folder I would generate or something. And then I figured out that I had it from the beginning, standing there. It's the node modules with all the libraries in it. And that's the perfect folder if you want to kill your performance. So that's how it started. And I've created a file search service like this one, which returns an observable here containing the items. Okay, so let's use it. I'm gonna take the file observable, which is an observable that emits the file names, the file paths of all the files in node modules. Well, those that finish with d.ts, the definition TypeScript definition files. And I am gonna take every one of them and read the lines in it. And I'm using the merge map so I can mix all the results, all the lines from all files, and they're all read almost simultaneously. So, and afterwards, for every line, I will filter the lines and only grab the lines that ends or includes the keywords I'm looking for. Well, this is a stream of lines that I want to turn into an array, so I'm going to use the buffer operator, well, the buffer time operator, because I don't want to buffer all the results. I want to buffer only for the 3 first seconds, because otherwise this will might not finish really quickly. It can be really slow. And for the demonstration, I want to give it a timeout, and I only want the first buffer. I don't want to buffer every 3 seconds. I want to stream with only one value at the beginning. And the last step, and I'm going to convert these lines into an object with items like this. Okay, now the typing is good and it's what I'm looking for. And let's see the results. So as you can see here, I'm monitoring the CPU and memory here. Well, I had to implement a little tool to get real live CPU and memory usage. And let's try to look for Angular, for example. As you can see here, it keeps using more and more memory, like 100 megabytes of memory. And we have a lot of memory usage, a lot of CPU usage. And while I can see that every time I'm running, I'm adding letters here, every request is canceling the previous one. But the problem is that the backend is still running, seems to be running the request for all of them. Let's see, like for example, if I send a long sentence like this one, well, you can see that I'm using more and more CPU and more memory. And even if I stop in the middle, it doesn't stop and it keeps running. So my cancellation is not propagated. As you can see here on the browser, I don't have any request running, but on the backend it keeps working. That's quite sad, but it didn't work. Why? That's the interesting thing. Why didn't it work? Well, it didn't work because it turns out that Nest.js doesn't unsubscribe automatically from the observables we return. We have to do it ourselves. Not for every route, but once. We do it once with interceptors. So Nest.js has an interceptor logic, which is quite nice, and it's really inspired of the Angular syntax for HTTP interceptors. And as you can see, it's just a service that will intercept every request, and it gives us the opportunity to modify the request and call the handler or the next handler or not. And then grab the response and consume it or not. So, and transform it or do whatever we want. So here, I'm gonna grab my requests and I will subscribe to the close event from the socket. Well, it actually works even with HTTP2, even though it's not the socket which is closed, it's the same event which is triggered. And we have an observable, which is created thanks to the from event function that adds listener to the close event. And we have an observable in closed dollar variable that will emit when the socket is closed. And why do we need this? We need this so we can unsubscribe from the result when the connection is closed. So as you can see here, I'm using the take until operator that allows me to subscribe to that response until the close event is triggered, and it will automatically unsubscribe from the handler, from the observable returned by the handler. Okay, that's great. Let's try again now. As you can see in the app module, I just have to inject the unsubscribe on close interceptor, which is exactly the one we have in the slides. So you can just grab every request and take until the socket is closed. Let's try it out. As you can see, it's not consuming lots of memory and a lot of CPU. And the interesting thing is when I start writing, if I stop all the requests and I cancel everything, it's going to cancel all the results, all the processing on the backend. And if I try again and just close the window, it will stop the processing on the backend too, which is quite cool. Now, let's try with MongoDB now. So as you can see here, I'm using dependency injection. And instead of using the file search service, I am going to inject the file search Mongo service, which has the same interface, but with one difference. It's that it's grabbing the results from MongoDB. Well, problem with MongoDB is that it was quite fast in performance, so I had to figure out a way to make it slow. Well, so that's why you can see this ugly code here, which is running JavaScript code in MongoDB to match every lines to the keywords. So don't do this at home. It's really bad. It's bad for performance, bad for security, and bad for maintainability. So just don't do it. And let's try it out. I'm going to just change one other piece of code here. Instead of watching the stats from my backend, I want to watch my stats from the MongoDB service. Okay. Now, this is MongoDB CPU and memory usage. First, I will remove the interceptor. And as you can see, we're just using lots of memory, lots of CPU, which is really bad for performance. And when I start writing and I stop my request, well, it's still running all the processing on the back end. Now I'm going to add the interceptor and try again. And as you can see, it's not burning up my memory and CPU usage. It's just super stable in performance. And whenever I stop sending requests, the backend just stops. So we are propagating the cancellation until the MongoDB database. Okay. So, and if I close the window, well, it stops immediately. Okay. So that's cool. But how does that work? Well, MongoDB has a concept of sessions, and you can start a session and end it whenever you want. Turns out that the end session function was not aggressive enough. So I used a command called kill sessions to kill the sessions. Well, turns out to work, but I didn't try on production yet. So I wouldn't recommend use it, but please try it and let me know how it works in production. But I'd be very interested to know your results about that. Let's go back to our slides. So as you can see, now every time we send a request from the browser to the backend, we are canceling the previous request, but it's also canceling the requests that are propagated to the MongoDB. We can also propagate cancellation if we are sending requests to another service, another microservice, or another API or something. Well, so now we know how to propagate HTTP request cancellation for every request we send and cancel. Well, so the key takeaways of all I want to share with you today is think reactive. So think about RxJS, check it out, try it out. There are other reactive libraries for JavaScript. There are other reactive libraries for other languages like RxJava or RxPython. Check them out too if you if you're using other languages, and use observables even if it's a single value streams. Of course, we immediately think about observables when we're working with streams of data, but observables are also useful for single value streams because they are cancelable and we can reuse the operators we know and stuff like that. With promises and async awaits in JavaScript, we don't have a cancellation logic right now. Do not ignore the teardown logic. If you have to create your observable manually, which should be rare, if you do it, think about implementing the teardown logic and return a teardown function. Otherwise, you'll have bad surprises with CPU leaks and memory leaks. And the last thing is that you can use RxJS everywhere. You can use RxJS in the front end, you can use it in the back end, you can use it with Angular, you can use it with other frameworks, you can use it without frameworks, you can use it in the back end with Nest.js or without frameworks. You can use it in your CLIs, you can use it wherever you want. It's a steep learning curve, but once you learn RxJS, it's really fun and it allows you to write like some complex logics with just one line or two. These are the key takeaways, and as it's probably not enough to make sure you're on the right path, remember that Marmicode is here to help you cook your apps. So we do online consultations where we talk about your architecture and code reviews and give you some suggestions of ways to solve your problems. And we run online workshops that you can find on marmicode.io. And if you want to get in touch with me, you can find me on Twitter. You can email me at kitchen@marmicode.io. If you visit marmicode.io, where you'll find our workshops, you can use the Accento promotion code and it will give you a discount on the workshops. Just notice that the O looks like the 0, but it's a no, so it's Accento 2020. And you can find the slides on the link below. Thank you for listening and watching, and looking forward to hear from you and your feedback. Good luck. Bye.
All right. Hi, Younes.
Hey.
Great talk. Thank you very much.
Thank you. Thank you for having me.
So basically, I think this is the burning question that the audience will be interested in. What's with the apron? I like the apron.
Well, the whole idea behind Marmicode is it's a word game in French. It's because marmite is like the pan where you cook, and code is code, so it's how you cook. And I think it's like the metaphor here is to think about developing cooking. I mean, like we all cook, but we try stuff and sometimes it fails. And when you take a recipe, it's good because you follow the recipe, and sometimes it just doesn't work because some things need more experience. But you try it 3 times, then 4, then 5, and you fail 5 times. At the 6th time, it's okay. So that's exactly how it works. So there's no magic recipe. Just apply it. Oh, Scrum is cool. I'm gonna apply Scrum. Oh, it doesn't work. How come? Oh, there's this framework. I'm gonna use it. It's not working. How come? So it's just an experience is failing. So that's the.
I can definitely relate to that. That's definitely my experience, mostly in cooking, but also in development. You're absolutely right. I'm always perplexed by recipes. The recipes in cooking books, they very often fall into the same pitfalls as online call talks or recipes or tutorials or something, or things where there's okay, assuming that you know all these things, all these special words that I'm using, so we're now gonna do this kind of operation, and you assume you know how to do this, and it's what are they talking about?
Exactly. And then you assume you have that special tool, and you're like, I don't have that thing, and my pen.
Exactly. What is that called? What is that thing? Okay. So thank you for the talk again, and to the people in the audience, if you're in the chat, in the booth chat for this talk, please put your questions in there, and we'll have a look there, and I'll repeat the question and answer them, and have Younes answer them or try to answer them. And Yeah, but what I wanted to get started is I was really, really interested with this this canceling example. It's actually interesting because canceling has been a topic in our workplace, like where I work at Dizzy. There's been a topic for the last a year or something. It's not an old topic, but it's quite at the moment it's quite important to us because we're running into this issue that we realize that we want to, when a user in the front end is doing all kinds of things like zooming in a map or something, we want to propagate cancel events down because we just don't want to be doing all that work. How did you come onto this topic of canceling? Like, did you have like a real project or something how did this come up for you?
Now, actually, it's really the use case I've used like in the presentation is this like search form, and it's quite common like when with the front end frameworks to cancel the request, but the thing is that we don't know what happens behind. So, and the other thing is it was actually the talk was more driven about like reactive programming in general. And I feel like most of the time people don't use observables, even if they know how they work, because they're like, oh, I'm just using one value, so I don't care about, just pop in one value, so I don't need an observable. And that's because we don't think about cancellation.
Right.
And if we think reactive like the whole way, this will propagate. We can propagate cancellation, and that's just one of the examples. So the idea is to generally think reactive. So once you don't need the data anymore, you just stop and it propagates.
Okay. I think that's a really important message. Also, the propagation that you mentioned, like to go down to the database, because if you just do a user, I mean, obviously you can cancel and just show the user next screen or whatever. But if you don't propagate it down, you're making the load, which you visualize very well in your live graphs. I think I would like to have that in my development system as well to see the live graphs there. I have a question from Samuel Sandro in the chat. So it's actually interesting. It's related to the canceling, and I was also wondering about this. How do the observables close the actual HTTP requests? What sort of mechanism do you know?
It's actually, I got to find the name. It's it's an API that it depends on what you're using below. But if you're using the fetch function underneath, which is like the new API for making HTTP requests, there's an abort controller, and it's like an object you give, and you can cancel the request.
Okay. And then do you think that the socket gets closed or something really, or is that like okay?
Yeah, actually, if it's HTTP1, the connection will be closed, and if it's HTTP2, it's gonna send like, I don't remember the exact message in HTTP2 to stop that how do you call that? Because it's not a socket, but that communication channel.
Yeah, I know what you mean, because it's in HTTP2, it's sort of can duplex, multiplex, and so on. So
exactly.
Yeah.
So,
okay.
Yeah.
Cool.
So that's how it works.
Okay. We have another question by Sebastian Schmidt. He's asking, am I right in assuming that there are certain requirements on the backend side to ensure that unsubscribing the request observable really makes the servers to stop working on the results? So when that's no longer needed. So for example, if he writes the backend himself with Java and Spring in this case, yeah.
Oh, yeah, totally. I don't know exactly how it would work with Spring, but definitely what you have to check out, and as you've seen here, I've been using Nest.js, and it wasn't canceling automatically. You have to implement something. So what I implemented was a little middleware that detects when the connection is closed, and then I can cancel the unsubscribe from what I'm doing on the backend. So
yeah.
The thing you have to check out is, do you have an event on the request that tells you that the connection below is down?
Right. Okay.
And yeah.
So that's somebody that somebody can look that up in the API docs for whatever framework he's using and have a look at your, like for example, in Java, I think you have the HTTP servlet requests, whether there's something there. And I think as just see, we have some feedback from Johannes Kissel there, who's saying that, yeah, maybe Spring out of the box doesn't have that, but there are ways to do then canceling in another way. So there's some hints in the chat regarding this. Okay.
Oh, okay. So they're doing, oh, wow. Okay. I see the reply from Joanne. It's very interesting. Yeah. So
Yeah.
it's a real challenge. And the problem, even if you have the event, well, if you're using something with an event loop on the back end, like if you're using JavaScript or stuff like that, it's
Mm.
quite easy to just add a listener and stop
Right.
your processing. If you're using Java in multi-threaded environments,
Mhm.
what do you do when the event happens? Do you run another thread that stops, that aborts your? That can be tricky. So you have to be like with an event loop system.
Yeah.
It makes it easier.
So what you described in nests and the way you showed it, it's definitely easier than what, for example, we do it. We have a Java backend and we do have to do canceling. And so we do it exactly as you say. So we have a separate request coming in to cancel, and then it triggers a separate thread that then interrupts quasi the running thing. So there's much more, stuff you have to do around it. It's nice if the framework sort of, or if the system sort of supports you a little bit more in doing that. In that
Totally,
sense.
totally. That's the direction. Well, it depends of. I mean, like, do you really need it? So that's the first thing. But the challenge here with the second, if you send something, like you request something from the backend, then you send another request,
Mm.
will that request end up on the same server? Is that
Yeah, you're right. That's you have to make sure about that. It's complicated. Yeah, that's definitely more
right? It's
complicated. Yeah.
really it breaks like the reactive thing. So that's also something I feel personally, and I use a lot of like JavaScript and serverless logic and cloud and things like that. And I think we are still missing a lot. There's something we have to do on the back end for all technologies to have more reactive architectures.
Yeah.
Like I want something simple where I can say I want to grab data, and if I don't want it anymore, it just stops everything. And when this happens, I want to execute this, and I
Yes.
don't want to use Kafka, and I don't want to use a message queue, and I want to use something more simple. And
Mhm.
like they're like cloud providers that try stuff like that with things like cloud functions and triggers and Firebase and stuff like that. But still, we're missing a lot of things, I think, right now.
Absolutely. And I don't think, I mean, React is, of course, obviously a huge part of this, the way you're talking about RxJS and reactive programming. But even if you're not in a pure reactive environment, and like we at work, for example, we're not, I think, in that sense, but even then, it would be very useful, and it's necessary, I think, that these systems react to these, that you can hook them into a flow like that and have them react to user-side events, because I've read about more reactive databases that can have like an event stream coming up to the client, so you can very easily subscribe to things. But this is the other way around, to sort of cancel operations going on. And we're working with, say, a more traditional Java Oracle stack. And for us, it's extremely important that we have queries running on the database potentially triggered by user action. That can be quite expensive, and it's important to be able to cancel those, because otherwise you're just taking away processing time from, I don't know, other people on the system, and it's just a bad experience. So I think we can learn a little bit about this this reactive approach here.
Yeah, I think there's something to do, but especially we can't. I mean, like users have to open like lots of windows and click all over it. I mean, like that's how we all use our
Yeah,
application, and
exactly.
we can't tell users, okay, so now you've clicked, you have to wait.
Exactly.
And if we don't allow the user to switch, or if we allow the user to switch and we don't cancel what's happening behind,
Yeah.
then we have like a performance issue. I mean, like whatever technology it is.
Yeah, I mean,
And
you had the example with the search query in your example. So you were typing like a big query, and there's lots of keywords in there. We have a similar example. So, for example, for us, if you go on a map and you zoom into or out of a map, and it has to load more data, and people keep zooming, right? And you're like zoomed in, and then you zoom back out. The people are not interested in seeing all the detail on that lowest level. But if you don't cancel anything, then your backend is doing like, oh, okay, you want to see the lowest level, and yeah, it's fun times.
exactly, that's a real good use case. It's
Yeah.
really
Because the
it's
mouse
really
wheel is ridiculously fast.
yeah. Yeah, that's true. That's true. And yeah, and or also if like you're moving on the map, that can also
Yes,
happen.
exactly.
Hmm.
One point I wanted to also take from your talk, which I found extremely interesting, and I want our audience to also to realize this, is you talked about debouncing. I mean, we often use debounds in our applications, and I think like a query field with an autocomplete is the typical use case. Like, you know, you're typing your query, and before you're done, you want to prevent sending like hundreds of requests or tens of requests to your backend system. But you mentioned in your talk that this basically it increases your latency, right? So everybody now has a latency of, I don't know, 250 milliseconds or 500 milliseconds, which is bad. It's bad user experience, because if I'm actually looking for this string or this key, then I want to see the result instantly. I wasn't really thinking about it that way, but now I'm really very skeptical about debounds. I will need to rethink that.
Yeah, it's a trade-off. It's a trade-off. And the problem is, I noticed that like if you're less than 15 milliseconds, the problem is that the debounce is not really useful, because
Sure.
users type, at least like most users won't type faster than that.
Yeah.
So you will send every keystroke. And if you go above like 100 milliseconds, it's human perceivable.
It, right?
You can feel it.
Yeah.
And I mean, like if you have like, it's really weird when you have like an API that responds in 10 milliseconds and you have like crazy good connection, and you have 100 milliseconds before because you just.
I mean, I think debounds is really sort of a lazy, or as a workaround for places where you don't have canceling. I would say, like, if you have really good canceling all the way down to the stack, then I would agree that it might be nicer to just have the quick response times in there. I mean, depending on the use case, of course. But.
Of course, yeah, it really depends on the use case. But if you're not paying by request, and if you're paying by CPU usage and memory, then it definitely or if you're not paying by bandwidth, then it definitely makes sense to think about the cancellation.
I hadn't even thought about the payment aspect, but that's true. Like in a cloud environment, if depending on way your billing is running, do you have experience with sort of deploying those systems or working on reactive systems in that context that are deployed in such environments?
Yeah, actually, well, I mostly use Google Cloud and some AWS. Not very familiar with Azure yet, but for example, with Google Cloud, if you're using Cloud Functions, well, the problem is that you're already paying for the Cloud Function. For every request, you're paying for the Cloud Function.
Okay.
But if you're using things like Cloud Run, where you have like just a container, and you give a Docker image or something, and it just pops up as many containers it needs. You don't know how many, and you can reuse the same container. Well, and you pay only per if you reuse one container, you don't pay for it, because if it's using, like, if one container is working for 80 requests in parallel, you don't pay 80 times, you just pay once. So if you're using containers, then it makes sense in terms of pricing. You will have like an economy. But I didn't make any experiments like really huge app with lots of volume and see the pricing at the end of the month. But in theory, that's how it works, and that's why on some applications I built recently, I've been using Cloud Run for that. For one of the reasons was that.
Okay, yeah, that's an interesting this aspect of billing. Like, you have the dimension of what is my user requirement, or what do I want to build, what sort of product do I want to do. You have maybe some efficiency things like how fast is it and how it is, and then you have this aspect, which I guess you already have also with traditional deployment, but it's not as visible. Like if people have a server running somewhere on premise, then it's like it obviously costs something, but it's not so clear. But in these cloud environments, it's crystal clear when you get your first monthly billing. Like, oh God, maybe I should do debouncing, or maybe I should do canceling, or whatever. Yeah, it's interesting.
Exactly, they can really change it.
I have an interesting point from Andoni, who's saying, like, to add one more, how to say this, a spice into this mix. Like if we're cooking, this is really cool also. In addition to being able to cancel, is that you want to be able, or you have to be able to cache things right at the right places. So that's also an aspect. Like the best request is the request you don't have to send, right? Or that doesn't have to go to the server, maybe even. Yeah.
That's true. That's true, and that's also with my friend Edouard Boson, we've been writing a library for it's an extension for JavaScript HTTP clients. Actually, it's mainly aiming Angular, but we're aiming like all other libraries. And we didn't talk much about it yet, but we'll be talking about it soon.
Okay.
And one of the features is to be able to control, like to decide if you want to use cache or not. And the thing is, I don't like trade-offs. And so the idea was I want network and cache. So the idea again is, as you're using observables on the client,
Yeah.
and that the observable can emit multiple values, like the first response, then the second. Well,
Yeah.
depending on your configuration, it can just grab the data from the cache, and grab it from the network, or both.
Okay. Okay.
So you can send the request, grab the data from the cache, display what's in the cache, then simultaneously go grab data from the network if you
Right.
can.
Okay. Okay.
And that's
So you have like a hot cache that you can use for very quick feedback, so to say. Okay.
exactly. And if the cache, if you, even if you have the interesting thing is that even if you have a hit on the cache, you're still grabbing data from the network and showing it up in the
So
browser.
that's your cake and eating it too, so to say.
Exactly.
Okay.
Exactly. Oh yeah. Exactly.
Okay.
And the idea is that, so that's just the beginning, and the idea is to make it way more configurable and say, okay, so this user is on has a bad internet connection, he's on Edge or something, or 3G, so I'm gonna use this strategy. And if he's having like a good connection, I'm gonna use this other strategy, and things like that. And yeah, no, we're not using the browser's cache. Well, we could, but we're not using the browser's cache because why is that again? Because you why again? Oh yeah, we're not using the browser's cache because we're trying to construct the data. If you have like a really RESTful API, we could update data in your storage. For example, it's like it's like if you are trying to create an image of your database, or for what your
Okay.
API is representing locally. So for example, if I grab a list of items, and if I update this list, I refresh it, then when I'm going to get one specific item on /item/item ID, I'm going to grab the one from the cache. One of the purposes is that you have a list view.
Yeah.
And when you click on detail, you don't wait. You get immediately the partial data you have in your list.
Yeah.
And then you can grab.
I mean, the advantage, I guess, browser caching can be quite, it can be very good to at least have the right caching headers and to sort of express your caching on the backend, like how long can we cache it. But what you're sort of saying is, it's almost like an offline first use case, right? So it's like like a little mini offline first thing where you're saying, the data is theoretically live. I want to get the latest data. So I definitely want the latest list of items, but I have a primed cache locally, like a storage where I have already the list from, I don't know, a few minutes ago or so at a time, and I can display that. And then I can sort of, in the background, fetch the new information and then incrementally upload it. So you're saying basically to the backend, I want the newest information, but on the client side, you want to say, like, I want to have very quick, displays and renderings, and then sort of incrementally update that. Right?
Exactly.
That's correctly. Okay.
So we're trying. That's exactly what we're trying to do, and we're trying also to provide like an API that makes it really easy. Yeah. So we want it to be also progressive, because the idea of progressiveness is that you have your app and you have nothing to do, and you just add this module, and you don't change your code, and it will magically try to grab it will make like both requests, one from the cache and one through the network. Then you can improve this and display like a banner saying, oh, this is the data from cache, and we're grabbing data. Or if it's really fast, you don't have to do that. So you can just make it show your cache data in gray, in a gray layout. You make it gray, and then you grab the freshest data, and then it's colored. So the user has like a really quick navigation feeling. So
there's even more high fidelity than like something like Facebook, where they, sometimes they first load the page with like placeholder images, like fake posts and fake profile photos, and then they fetch the data, and then it gets updated. So that's even a more advanced version of something like that.
Exactly. Okay. So the idea is really similar, but you have real data. I mean, like you open your mobile app, your bank app, and you have your bank account status from 2 days ago,
Mhm.
and it's all right. It's because it still shows that it hasn't been updated since
Right.
and stuff like that.
So there's a note from Andoni who was talking about service workers and the tech behind it. Is that something you're using in this library? Is service workers a technology you've used there?
No, we're not, because for the moment we're thinking about it, because the problem with the service workers, I noticed, but maybe I'm wrong, is that if you use the service worker, it's acting as a proxy for your requests.
Mhm.
And the problem is that you can't reply with two responses. You can
So
reply,
okay, to the client, so to say. Yeah.
yeah,
Okay.
for the client. So the client will ask you for something, and you
Yeah.
as a service worker, you have the data from cache. You know how to grab the freshest data. You know how to grab the data from the browser cache, and you know everything. And then the client asks you for something, and you're like, okay, here's the data from cache. And now it's too late. You just closed the communication. You can't send another response because it's not based on observables.
Okay, yeah, that's true. That's the observable bit is the important bit there, right? So you don't really have, you just have an HTTP API quasi, but you don't have a real observable layer in front of that. Okay.
Exactly. So you have one request and you have to reply with one response. So that's why we didn't use it, and we didn't want to hack through multi-parts and stuff like that.
Sure.
Responses. So we want to make it simple.
Yeah.
So it didn't work out. And plus the other thing is that we want it to be lightweight. So you just use your app and you add this module and it works with your browser. And we didn't want to, like, you don't want to add third-party libraries in your service worker scripts, because like it's always tricky and you don't want it to mess up your stuff. So, but the main reason is that the API doesn't allow us to pop up multiple responses.
Makes sense. So I understand that for you, RxJS and reactive programming is sort of is native for you, right? You have a lot of experience with it. For me, it's quite new. I've read about it. I've never used it in Angular. I've maybe made one toy project or so, or in a course. Do you have any tips for people getting started? Because I think it's still not widely. I mean, at least that's my view. I don't know. Maybe it is widely used by people, but. Do you have any tips on how to get started? What's a good way to sort of introduce or learn about it and then introduce it in a project which maybe is not reactive? What would be?
Yeah. So I totally agree with you. It's the first thing is one of the main problems with the RxJS and reactive programming in general is that you're like, you have to learn something new to make your app work, while you can still make it work without it. So
Right.
it's like an optional thing, and it feels like it's an optional thing, but the learning curve is really steep, and like there are so many things to learn to really make profit from it. And the other thing is that clearly, like through my Angular workshop and training experience, it's clearly one of the top 3 hardest and most requested topics in Angular is testing. Of course, that's the most common in all technologies, and the other topic is RxJS and reactive programming. So how you get there? One of the cool thing with RxJS is that there are a lot of tools online that help you visualize reactive RxJS operators and stuff like that. One of my favorites is RxViz. I'm going to share the link on the chat.
Yeah, please do.
RxViz.com. That's a really nice way of visualizing it and see how it works, because it really displays like all the marbles and stuff.
Is that with the marbles, like the lines with the balls in it? I've seen the diagrams. Yeah, okay.
Exactly. And it's animated and everything, so it's quite nice. And the other thing is RxJS own documentation. It's really like, it wasn't like at the beginning, of course, like most APIs, most libraries, like you don't have much time to make like a great documentation, and you need more feedback from people to build the documentation. The official documentation is quite nice, gives like the idea. And one of my favorite thing, and it's not everybody knows it, it's hidden in the documentation. There is an operator decision tree.
Okay.
So because one of the main problems with RxJS is that you have like hundreds of native operators, and most of them do like uh, some of them are really easy to grasp, others are more complicated, and the hardest thing is to think about all the combinations you can have with all the operators. And the operator decision tree is really nice because it allows you to it allows you to start from your use case.
Hmm.
So you give it your use case, and it asks you a couple of questions, and it ends up showing you the operator to use. So
Cool.
it's quite nice. And the other thing about like like our XJS, one way of learning it, it's there are two things. One thing is to try to think about all your use cases, like start from a use case, like something you want to do reactive, and then try to do it. And then the RxJS community on Twitter, for example, is really cool. So just shoot your questions or let me know. And there are a lot of people who will try to help you with that. And well, anyway, you have to like try to figure it out. And the other thing I do personally, like every couple of months, I go on the documentation and I go through all the operators.
Okay.
And then you know why the first time it's very interesting, because like the first time you understand only like two or three of them, and then all the others like forget about them.
I
And
did
then
go through that once. Yeah, that's a huge list.
yeah, see, and the 3 months later you read the operators, you're like, oh, this is the one I would have used like 3 weeks ago when I implemented that whole complicated function. And then
Okay.
the other thing is that the first time you're going to use RxJS, you will end up combining like 5 operators, and then you end up using only 2,
Okay.
and stuff like that. But
I
the,
see.
the main thing is try think reactive, so to combine like the operators and try to avoid setting variables globally
Mm.
in the middle of the pipeline. So
I mean,
that's
that sounds like really good advice. And you posted a link to the operator decision tree.
yeah.
The chat I see. Johannes asks, and that sort of goes into this direction of how to get started. So you're asking if it's useful to add RxJS or reactive programming as like a utility, like say for example a Lodash or something, and or do you get only the benefits if you go whole hog, like if do the whole application in reactive style? What's your opinion on that?
Oh no, you can totally use observables like RxJS, like a library for some special parts of
Mm.
your app. You don't have it's not a framework. You don't have to be reactive all over the place. At the end, you're just with RxJS, for example, or not. I'm not talking mainly about RxJS, but it works also with all other
Yeah.
ReactiveX libraries. Is that you just end up creating an observable, which is something you subscribe to,
Mhm.
and that gives you the data you want, and then you call whatever you want. So it works in with whatever technology you want. Like for example, sometimes I use I use Rx Python and in my Python apps, and sometimes I use it just to emulate messaging queue, an in-memory messaging queue, for example,
Right. So
and just
you're
have a
able to
couple of
work with events. Yeah.
and you have a stream there and you can manipulate it. So that's one basic use case.
Yeah.
And of course, in the backend, it's a little bit more complicated than with RxJS in general, because you have other concepts with Rx Python, for example, is
Mhm.
that you can subscribe to an observable in another thread. So you have a thread which is popping the values, then you have another thread that
Mm.
grabs the data, or you can have an operator that transforms the data in another thread, and
Yeah.
stuff like that. But the
That's,
thing is,
yeah.
clearly you can add it, and you can see it really like as a third party library. You can add whatever you want. But the thing is, with RxJS, the funny thing is that we always spend like an hour for one line, but at the end, if you want to try to implement it manually, it would take like 100 lines. So
Okay, yeah, that's always worth it. If you have to think more and then write a little bit, I like that. That's a good sign. If there's a lot of thinking and a little bit of writing, that's a good sign.
that's exactly the idea behind RxJS. But the learning curve is steep, and you shouldn't be discouraged. I mean, like, try, and there's a lot of people around trying to bring content around RxJS and to.
I like your idea, like you said in Python, with maybe adopting it as a little memory message bus, so to say. For example, often you have systems also in a backend, maybe also front end, where you're working with events. Like I'm thinking about a system we have where you're working with events and doing things on that, even on those events, and then writing them somewhere else, maybe passing them on. And it's a typical sort of thing, right? Where you want to also maybe have back pressure. You want to have some operators, like, I don't know, I want only the first whatever, or I want to do, and then it could help really to have this thing in your toolbox.
Yeah,
so it could be quite useful.
Totally, that's really a good start, and that will help you like learn like the first basic operators like map and filter and stuff like that. And then once you get familiar with that, you can propagate to other use cases.
Okay. Yeah, very cool. I think officially where the slot is through, but I definitely wanted to ask is, you mentioned this library that you're working on, and other things I assume that you've created. What would be the best place to get a hold of that? So do you have like, what's your preferred way for people to get a hold of that stuff?
Oh, so I'm trying to regroup everything on marmicode.io, but it's not all there yet. We're working on it. And otherwise, I tweet about most things. So my Twitter is
Twitter is a good idea. Okay,
here's
cool.
my Twitter handler. And all the other stuff, my open source project, you will find them on my GitHub here, or on github.com/marmicode. And otherwise, there will be, I'm trying to regroup everything currently on marmicode.io, so you can find all the open source libraries and stuff like that. But in fact, like for example, the library I'm talking about it's not we didn't communicate on it enough yet. So
yeah, well, we'll see a tweet about that. And I think Twitter would be a good way to get notified when that's
I'm preparing something. I'm preparing like a blog post and everything. And yeah, and the blog is on you will find me on Dev2. I'm sharing the link.
Okay.
So I publish on Dev2, and I still have some old articles on medium.com too. So that's a couple of links there.
Yeah, that's, I think we know where to get all the stuff. Well, Younes, it was a pleasure talking to you. It has a very interesting topic. I learned and I thought about a lot of things. Like I'm definitely going to be trying to think about how to incorporate these ideas, or to think a bit more about canceling, about debouncing especially. I want to revisit debouncing. And so really thank you very much today for your talk and for being here with us on Accento.
Thank you again. Thank you for having me, and thanks for all the people who are here and all the questions that are very interesting, and that makes me want to go search for a couple of things online and share more content about RxJS and stuff like that.
It's the best thing, right, about a conference. Like you feel like energized and wanna dive into that stuff.
Totally. Lots of interesting input.
I think we can find you again at, let me check, I think 2 o'clock UTC or 4 o'clock Central European time. You will be doing the TDD is Dead, Long Live Timebox TDD and TCR talk, an Ignite talk. And I think at 1600 or 4 o'clock UTC or 6 o'clock CST would be the tests and code and mock and roll.
Exactly.
Sounds really interesting.
Exactly. So yeah, see you at 2 UTC, and it's framework and technology agnostic. So there'll be a little quick example of like some extreme ways of testing. So check that out.
I already have a bunch of questions piled up, and see if I can ask them there. Then thanks again, and we'll see you at the Ignite talks then afterwards.
Great.
Bye.
Thank you. Bye.